Hey, welcome everybody into the NGK Tech Garage. Thanks for joining me today. Today we, like the title suggests, we're talking about wiring repair. Now I know there's been a couple videos in the past on this channel regarding wiring repair, and this is kind of a sequel or a follow-up to something that we've done in the past. Plus, we're going to take this a little bit different direction. Now, like I said in the chat just shortly before, there are quite a few videos out there already on how to solder a wire or how to connect two wires together, or whatever it may be. What I have today in store for you guys is something that I haven't seen out on YouTube before. I got a couple different tests in mind to play with some wiring connections that that nobody has shown before. So let's get right into it. First of all, the t-shirt question is going to again be at the end of the broadcast. I know we used to do it at the beginning, but again, it's going to be at the end. This is what the new t-shirt looks like. Congratulations to the 5 winners that won it last month. You will get the opportunity to win this again at the end of the broadcast. That question will come up right at the end. First 5 people to get me in a correct response will win a new shirt. And if you won last month, I will give priority to one of the newbies who has not won yet. Excuse me. I do have a little bit of a cold going on still. It's just that time of year. So these are the wires. For those of you that watched the video in the past, these are the wiring connections that I've had underneath my truck in the wheel well now for the last 2 Wisconsin winters. Yes, that was 2 winters ago. Here's what it actually looked like when it was on my truck. I cut these off of my truck yesterday so that I would have them ready for today, but they are just, I just had them zip tied to one of the back rails just behind the wheel well in my truck. So you can see they are all here. I have not cut them apart. I haven't done anything with them besides take them off the truck and bring them in here. We'll do that live on camera today. So also, I have a thermal imager set up here, which we will be taking a look at our wiring connections. I also have a load test set up, so we're going to use a 6 amp headlamp today to do a load test on our circuits, which I have hooked up to the lab scope. So we're going to measure voltage drop across these wires, and we're going to measure the amperage, the flow across there, and we're going to measure temperature with the thermal imager. But that's not all we're going to do. We're also going to look at the tension test of what it takes to actually pull these wires apart, okay? So actually here in the facility, we have a machine, this guy right here, that you can put in pretty much whatever you want, whatever fits in between these jaws, and you can put them between there, and it is going to measure what it takes to pull that apart. So we're going to measure the tension or the force that it takes to pull that apart. So I have some data revolving around that as well. So just checking in on chat. Let's take a look at the chat real quick and see what's going on. I'm so happy with your NGK shirt. Nice. And I'm sorry I didn't get more blue wrenches handed out today. I will, by the next one, I will have have some more blue wrenches in here. Keith is the only one to today. Lazaro, t-shirts are going to be coming up at the end. No pocket on this one, unfortunately. I would send a shirt off to France. If you are the winner, I will send a shirt off to France. So, okay, before we get into actually testing up these guys, looking at the wires that I pulled apart in the tension tester, I wanted to just go over a couple of the common, let's call them approved connections, right? So wiring repair, in my mind, is kind of like the old, where you kind of choose your brand, right? The Ford guys or the Chevy guys or the Dodge guys, you know, whatever it might be. Wiring repair is kind of that way too, right? You have your guys who only want to solder. You have the people who, you know, only want to do heat shrink butt connectors, and then you have the people who, I don't know, they like to start dashes on fire, right? They twist wires together and put tape over them. They're kind of in their own group as well, right? So we're going to go over just a couple of the, let's call them approved or common acceptable wiring repairs today, how to do them, how they work. We got some really good close-up shots here that I'm going to show you guys today, and then we'll get into actually testing out these guys. So when it comes to wiring repair, obviously we got a bunch of tools here. You can get yourself a wire cutter like this, that it's a cutter and a crimper all in one. You can get yourself a crimping tool like this. These are pretty nice just for cutting and crimping. You can get a pistol grip stripper, wire stripper like this. This is nice because it usually doesn't cut into the wire. If you take and you try to strip wire with this right here, if you pick the wrong size, if we get a close-up here, if you pick the wrong size wire here to strip this one, you can actually end up taking some copper with it. So if I pick 20 gauge, I'll actually pull some copper. There's actually some copper strands left in there, okay? When you pull those copper strands out with it, now you got an issue. So what's really nice about this style is it's not going to pull, it's kind of just automatically right size, so it's not going to pull those copper strands out with it. So super simple. Doesn't actually dig into the copper here and create a weak spot either, where this one can actually dig into the copper and create a weak spot. So these are great. They're super fast to use. I'm sure they're on just about every tool truck out there. So with that being said, let's go to probably, first of all, my favorite connection method, the heat shrinkable butt connector. You can pick these up at just about any store out online on Amazon or wherever you're shopping. And of course, this is a brand new pack that's still taped shut. All right. So these are a crimp style connection. Take a look here. Crimp style connection that is heat shrinkable. Now be very, very careful when you're putting these on wires. If you're using a pliers like this or like this, either way, you want to make sure you're doing the one that's made for insulation. If you use this one right here, you're going to actually wreck the sealing surface of that plastic, okay? So you want to make sure you're using the one that's made for insulation, which is actually the middle one here. It's this one right there, okay? That's the one you want to use because it's made for this insulated connector. We don't want to expose that metal crimp connection there. We don't want to expose that to the environment. Otherwise, we're going to end up with corrosion issues. So let's just go ahead and do one of these the right way quick. We'll snip some wire here. Get one end in there. Actually, if you want to pull up the other camera in the, we can go picture in picture on this part. And then when we're doing this, we want to make sure that we're twisting our wire, first of all, okay? So we want to twist the strands all together, twist the other strands together, and then we'll put them in our little thing, our little jig here. Now, obviously, this is way easier to do on the table in front of me than it would be in a car, but we'll get this fed in here. And ideally, you don't want copper sticking out of the end. Let's bring that up full screen so they can see. We don't really want to see our exposed copper out of the end there. Obviously, it's still going to be protected, but we can trim a little bit of that away. That way, there's less exposed. Okay, like so. Tighten it down. Same thing with the other side. I'll trim some away. Again, these are super easy to use. I've been using them for a long time, and they work good. And we'll see on the long-term test how they actually did. So we're just going through this really quick. And I'll heat shrink everything at the same time later to save some time. Put that in here. Actually, we'll probably do it now. All right, like so. Actually, right here, you want to be careful that you don't miss any of your strands. Because again, that'd be just like cutting a strand. Like so, crimp it down. All right, now we just got to heat this guy up and it'll be a sealed connection. So you can use a heat gun like this one right here. You can use a butane torch, you can use a lighter, whatever it's going to be, you want to get this guy melted down. And when we melt this down, we want to go from the inside outwards. We want to force the glue, the sealer, outwards towards the edge. So we'll let this thing just melt down real quick. And you can see it's starting to melt there on the edge. And you got to use the right size, otherwise it's not going to seal properly around the wire. If you use the wrong size connection, you're not going to have a good seal. All right, and just like so, we are sealed up in a weatherproof connection. And we do have one of those in this Luma wires right here. That is properly done right there. We have one in here that's actually properly done and one that's done improperly. So that's one connection method. And that's one that I've used a lot in the past. I've used this one numerous times in the past. Has been my go-to for quality wiring repair where I don't want to solder. Maybe I don't have the room to solder. Maybe it just, for whatever reason, I'm not soldering that day. I go to this guy. This is a great connection that I've used in the past. We'll see how it lasts in here. Now these guys, there's been a recent video showing these style connections. Car questions, huh? There's not going to be a car in this video, unfortunately, guys. I do have some cars in the shop here that I'm going to do some videos on, hopefully in the very near future. But today we're going to just do some wiring repair. So these guys right here are kind of a new style connection that has been showed in a couple videos. I was actually turned on to these by a viewer from Hayward's Automotive. Bob suggested that I get this brand. And these are a crimpless solder connection. So you put the wire inside of here, you melt it down. Now, I learned from Oz Mechanic's video that you don't want to use a torch when doing these because it'll actually overheat and melt down the plastic on the outside before you actually melt this thing in. It burns the clear plastic before you get the solder to melt. So we're going to use a heat gun on here. I'm going to strip a little bit extra wire off of this because I want to twist these guys together. You could either do a fan style where you take the wires and kind of splice them in like this, or you can take them and you can twist them into each other. We're going to do the twist one for this today. All right, so we have one end of our wire, we have our other end of our wire. I'm going to just overlay them a little bit, and we're going to just twist them together like so. It's kind of like a lineman splice. It's not nearly as technical as the lineman splice is, but something like that, that's a pretty adequate wiring repair connection right there. Of course, you always want to make sure that your connector's on there, right? Just like when you're doing a brake line, you always end up flaring the line before you get the nut on, right? Well, this is the same way. There's actually a larger end and a smaller end. Smaller end, larger end here, okay? So just keep that in mind when you're putting these on. Make sure you put it over the wire first. Otherwise, you're going to be having kind of a rough day. So we'll feed the wire, the large end over. And we want to kind of have this centered over our connection here. Something kind of like so, right? Looks pretty good. So we're going to take the heat gun now, and I found, I was practicing with these a little bit before the video today, and I found that they take quite a while to actually heat up and melt. So we'll get that out of the way. So let's show you guys in real time what it takes here. We're centered on there. And you'll see everything melts down with the clear plastic pretty quickly. Right, it's shrinking onto our wire pretty quickly. Again, we're going to work from the inside out, get any air out of there. And again, you don't want to use a torch on these. You will burn this clear plastic before you ever get the solder to melt. And already you can see the solder wicking into the wires, right? Let me grab the remote here and I can zoom you guys in a little bit. See how the solder's wicked into the wires? So it doesn't take really that much longer than a crimpable connection, right? So we're not looking at a huge difference in terms of time. Oh, let me get my head out of there. Not looking at a huge difference in time to make this happen. So it looks like a pretty good connection there, right? Again, my head's in the way. But we'll let this cool down. But overall, the solder flowed. You can see it's still kind of a chunk in the middle, but it definitely flowed all the way through the wiring, all the way over to here. So we did have some solder flow. It looks like it's a good connection. So we'll set this to the side right now, and let's do a quick solder repair with two different types of solder repair. I'm going to use the 12-volt Milwaukee soldering iron today. You guys can use whatever soldering iron you want. You don't have to use this one. You can use whatever you want. This one's nice because the head locks in different places and it's battery operated. And it heats up super quick. So I'm going to strip a good amount off of here. We're going to start with a lineman splice. This is going to be what's considered to be the strongest splice for wiring, but you do need quite a bit of wire to do this. So I have both my ends are spliced right here, or I mean are stripped here. Let me zoom you guys back out a little bit. Okay. So both ends are stripped with a good amount of wire. We're going to twist these. Like so. Move that guy off to the side for now. And what we're going to do is we're going to create a 90 degree like that. We're going to put them in here like so. And we're going to start by going around like that. Okay? So that's what we got right now. And then we're going to wrap these into coils as tight as we possibly can. And by the standards, it's supposed to be 3 coils on either side. And we want these coils to be tight up against each other. So that's what it looks like when it's complete. Zoom it in a little bit here. Right there. So we got them spun over each other and then coiled around there. So as we pull on this splice right here, it'll actually tighten everything up together. So we'll go ahead, we'll put a little bit of solder on here and finish up this connection. Of course, a soldered connection needs shrink wrap over the top of it, okay? I'm not going to bother showing the shrink wrap today, but just make sure you put your shrink wrap on the wire before you make your connection. Otherwise, the old brake line and nut analogy comes back into play. When you're using solder, don't buy the cheapest solder you can find. You'll find that it doesn't flow as well. Also, make sure you're not using acid core solder. Acid core solder will actually eat away at your wires over time. You're going to want to use rosin core solder. And then if you get some, like this is super fine stuff that we have here in the factory that works really, really nice for this kind of thing. Don't breathe this stuff in if you can avoid it, you know, well-ventilated area. Safety glasses, safety first. Daniel, this video is going to probably be about an hour long. So we're going to, actually, it's probably best to just tin the end of the soldering iron first. Just get a little solder on there. And then we're going to heat the wire up because we want the solder to flow into the wire and we don't want a cold solder joint. If you just heat the spot that the solder is supposed to go on, it's not going to flow into the wire. We need the solder to flow through the wire so we don't end up with a cold joint. So eventually here you'll see the solder starting to flow, and what it's doing is it's traveling to the heat source. So it's flowing and wicking through the wires. Again, well-ventilated area. You don't want to breathe in this smoke. We'll just cover the last little bit of the coils here. And again, we're heating the bottom side of the wire. Go ahead and leave that on for the moment, but you can see we have solder flowed through the entire thing. Now you could use some flux on here as well. There's probably people mentioning it in chat. Yep, there you go. I always use flux before soldering. So Yeah, you can definitely use flux on here as well. Did we get to the part where wire nuts are best yet? Yeah, we're getting there. So that's a lineman splice. Theoretically, this is supposed to be the. Okay, are we back? I think we're back. All right, I think we're back. Make sure we're working here. All right, I think I lost you guys for a second, but I think we're back now. We should be good, right? Okay. So yeah, lineman splice, super strong, but again, we put it in the tester, and I'll show you guys what the results were from that. And then the other one, you can do like I don't know if there's a proper name, fan, where you kind of fan the wires apart and splice them in. So I'll show you guys that one. This one doesn't require as much wire to do. So again, we're just stripping the ends off of each of them. So that way we have this right now. So I'm not going to twist these yet. What I want to do is I want to kind of spread them out a little bit. Get them all fanned out. And then I'm going to kind of run them into each other like this. And then we're going to twist them together. Like so. What's nice about solder connections is you can see how small the wire is right now, right? It's not any larger than the insulation. They're very unobtrusive in your wiring harness, which is nice. Where like this is pretty good, right? It still sticks out a little bit, so when you tape it all back together, you might be able to see it. But overall, these are, like I said, these are 4 connections that I would recommend using on a vehicle because wire nuts are not best, and I'll prove it in just a little bit. Now those marine grade wire nuts might be different, but we'll see. So again, just going to apply a little solder to the tip of there, and then we'll apply solder directly to the wire itself. Like that. And then just quick throw some heat shrink over the top because again, you want to make sure, same thing with getting the right gauge wiring for the repair, you want to make sure that you're using the right gauge heat shrink. This one is a little bit big. Let's go down to this size. Shrink that down onto our repair. Now I've also heard of people putting a little bit of dielectric grease or something around that repair first and then putting heat shrink on. But after you heat shrink this down, there shouldn't be any water getting in there anyway, unless you somehow damage the heat shrink. All right. And there's another successful, good quality wiring repair, okay? So really, between the fan style, the lineman splice, these new crimpless style, and the heat shrink butt connector, these are really 4 connections that I would say are going to be good connections on the car for long term. Obviously this one would need heat shrink over the top, but for long term sustainability for the vehicle, these are 4 good connections that you can use. But let's take a look at what they do in an actual stress test when we're trying to pull them apart. Let's take a look at that data that I've captured. Get all this out of the way. All right. What's going on in the chat? All right, everybody says we're working again. Engage the safety squints. Yeah, I've disengaged the safety squints. I like the Milwaukee heat gun. I like that it's portable. You know, it matches up with the other batteries that I have sitting around, so that's really nice. So I like that gun a lot. Use dielectric grease in that non-glue type heat shrink. Yep, use heat shrink with the glue in it. That's going to be the best. You just want to protect that wire from the elements. You're soldering under these. Yep, exactly. Joe, you're totally right. If you're soldering laying on your back underneath the dash, it's a lot different than doing it here. And that's why a lot of times I won't solder a connection. It's a lot easier to do a heat shrink butt connector, or maybe one of these, because you get that positive connection of the crimp. You know, you get the crimp connector in the pliers, and you're under there laying on your back. You're trying to shove that wire in there, and you get it right in place, and you quick crimp it down so it doesn't go springing back into the harness. You know, we've all been there. Sometimes it's easier to do other types of connections depending on what you're doing at that moment. If you have the space, if you have the room in the harness, throw some solder on it. If you don't, throw one of these in there. Do whatever makes you feel best. But I'm not going to tell you guys which one to do. I'm going to provide you with data over these and the tension test, and I'll let you guys decide what you want to do. So here is our data. Okay, so up on the screen right now, guys, you're going to see a whole bunch of numbers. Right? No cheating. Why is that still up there? Let's take that down. Okay. So here's a whole bunch of numbers. This is our data from pulling all, I think I had 10 different connections in 18 gauge, and I had 12 different connections in 14 gauge wiring. And this is the data that was captured. Now I put this in a line graph. Here's 18 gauge, here's 14 gauge, to look at the tension strength of each of the connections. So let's go ahead and we'll just look at 14 gauge today because, well, the data is similar, the connection types are similar. So we'll just look at 14 gauge. So we're going to deselect all, and let's start with the twisted and taped. Oops. We'll go with just one. So twisted and taped, you can see what we're doing is we're stretching this over time, and this is pound-feet of force. So at just under 9 pound-feet of force, we begin to separate that connection, and obviously as we're stretching it over time, we are requiring less force as it's pulling apart, okay? And you can see we just yanked it apart right there, right? So they were just twisted together, some tape over the top, and it was pulled apart. Not too impressive, and we really didn't expect it to be impressive. Let's jump up to our wire nut. Compare that. Our wire nut was actually less impressive. You can see a steady ramp up in terms of force needed, but then the wire nut popped off. The wire nut popped off, and we eventually pulled the twist, because the wires were twisted together, pulled the twist out of the wires, and that's what we're seeing with that one. Still, not very impressive. We're under 10 pounds of force to pull those apart. Now, if we throw in a non-heat shrink connector, so that's going to look like this kind. The kind that you a lot of times will see underneath the dash. If we get a close-up of that, you'll find that remote start shops will throw these in there. They're not protected from the environment. They're quick and easy and cheap. And they're just a crimp-style connection, okay? So let's take a look at what that one does. Significantly more force to pull that apart, right? Here's the first two. Now we're up into 90 pounds of force to pull this crimp connection apart, okay? 90 pounds of force, that's huge. But the biggest difference I found with this is we did pull apart at the crimp joint. So here's your wire nut. That was the wire nut one. But look at this. We actually separated the wire. Oh, sorry, I'm holding the purple one. Let's get I got somewhere over here. Uh-oh. We might have lost the crimp connection in the pink one. But with that one, it actually separated out at the crimped connection. Oh, no, it didn't on this one. The purple one did. This one separated out in the jaw. So we actually broke the copper. The copper broke in the strands of the wiring, and it didn't break at the crimp connection, okay? So we actually broke the copper, not the connection. So that's a really, really strong connection, but it's not environmentally sound. It's not going to work on our cars, okay? Let's take a look at the next one. This is just a lineman splice with no solder on it at all. So we get a little bit more strength out of it than just a twisted pair of wires. We're up to maybe 15 or so pounds of force on there. Not too much, but more than just twisting the wires together. and it took a lot longer to separate the wires. You can see we're still going out on our graph, a lot more time taken. So this next one is heat shrinkable butt connector. Similar to the crimp connection. Let's take a look at what that one looks like. There's our linemen. So here's our heat shrinkable one. Now what I found with this is our wire actually broke inside of here. Okay? So where our wiring broke right here, it actually broke right about here at the crimped joint. Okay? So it's almost like that when you squeeze that pliers down and you crimp that down, it actually is not damaging, but it's actually weakening the wire at that spot. Okay? So when we crimp something down, when we put a pliers and we put force on it, it's pinching those wires together underneath that metal crimp inside here, and it's weakening the wires at that spot. Okay? So let's keep that in mind. Let's jump to the next one. We have, this is a crimpless connection. This is one of those, one of these guys. Okay? This is the ones where you just heat it up. Looks like this one, right? Just heat up the connection, crimpless. And all I did for this one was I fanned the wires together like this, twisted them, and heated it up. So let's take a look at what that looks like. That's going to be our blue line, which is getting messy in here. Let's pull some of these out. I'm going to just have that one. Oh, sorry, that's gray. I lied. Okay, it's green. 5 pounds of force, guys. Okay? This connection right here, fanned together like this and shrunk down. You want to get a close-up on there? Thank you. This connection right here, fanned together, took 5 pounds of force, just over 5.1 pounds of force to pull this connection apart, okay? It's really nicely sealed by the looks of it, but it only took 5 pounds of force. Now, if we compare that to that same fanned connection with solder on it, let's take a look at what that looks like. A huge, huge difference, right? We're up over 100 pounds of force required to pull that fanned connection apart, okay? With solder on it. So it's a much stronger connection with solder than it is with these type of connections. But what I want to point out here is look at this picture. This one here. Let's bring that up full screen, please. You can see, and I'll zoom in, we didn't break the wire. You can see there's a little bit of solder tinge on there, right? The solder didn't flow onto this wire. It flowed onto the other one, but not this one. Now, maybe if we put some flux on these wires first, it might flow better into the other wire. That's very, very possible. And that's something that maybe I should have done ahead of time, is had one with flux in it and one without. But I went just, so everything remained consistent, I went with no flux on any of our wires whatsoever, just so that we could remain consistent with the experiment that we ran last time. But I have a feeling that flux might change this, but you guys just need to keep this in mind when you're using these connections. We're proving out here it's not as strong. The solder did not flow over to this one. And if we go over to the next picture, you can see the this was that same fan-styled connection, and we actually broke somewhere up inside of here in the insulation. We didn't break at the connection point here. We broke somewhere inside of the insulation. So the copper itself broke. And we can see that copper breaking right here. Okay? As each strand of copper breaks, we can see that right here. And this was probably multiple strands breaking. All right? The next one was a lineman splice crimpless connection. So again, this is the proper lineman splice and then put into that crimpless style. And we're pulling 26, 28 pounds of force on there. So it's a lot better than just fanning them together. You know, maybe that helps the solder flow, I don't know. But it is holding better. But if we compare that again to actually soldering it, again, a huge difference. This one was up to 80 pounds of force, which I found odd that this one would be less than the fan style connection. I found that to be odd. But either way, we're never going to be subjecting our wire to 50 pounds of tugging force plus. Really? I mean, our harnesses really should never have any tug on them at all. But again, this was just to prove out what works best and what doesn't. Let's just look at a cold solder joint. This is what a cold solder joint would pull apart at. So this is 25 pounds of force to pull that cold solder joint apart. So it's a lot weaker than a standard good solder joint, okay? So I guess just all in all, we're proving out that these guys, these right here, if we go close up, because there's no crimped connection and we don't know if the solder is flowing perfectly, they're not as strong as a soldered connection or a crimp style connection. Now, with some flux in there, it might be different. Maybe I'll do a follow-up quick video throwing some flux on there, seeing if it flows better, seeing if that low temp solder flows better. But overall, we're still able to get 25 pounds of force on that wire. That's way more than our harness should be subjected to anyways. So really, it's going to be, again, your choice to make, but I don't see it as a bad connection, okay? Not like the wire nut or twisting a pair of wires together, okay? Take a peek at the comments section. And yeah, Keith, you're exactly right. At what time would 5 pounds of force be on a wire? I completely agree. But this was the variable that I could test. I wanted to see what connector was stronger than the others. I wanted to be able to pull on them and see what held up and what didn't. And that's the way I kind of made this all work out. If we pull everything, all the data on the screen again, you can see there's really no middle ground on here, right? We have some connections that I would say failed and some that passed, okay? So these are our two crimpless connections, the twisted pair, the wire nut, and the lineman without solder. Those are the connections that I would consider failed at this point, and these are all passing. Okay? Take a look at those comments once more, make sure I'm not missing any questions. All right. Okay. The lineman splice does meet NASA standards, yes. Okay, so now I think we can jump into these guys. I think this is where the fun is going to begin. I'm going to cut these apart. Putting safety glasses on for this one. I got a fire extinguisher over there just in case. Let's take a look at what we have set up. So I'm just going to draw out what's currently set up with, we got a power supply here running to a 6 amp bulb. It pulls 6 amps. This thing's putting out 13.6 volts, I believe. So we're running 13.6 volts down to our, this is our bulb 1. So that's our bulb. Ooh. And then we're running that to ground, okay? So what I've done is I got bullet connectors in here. So we got a bullet connector here and a bullet connector here, and that's where we're going to be inserting our wires, okay? We're going to be inserting them right into this point right here. So they're going to just be on the power feed into the bulb, and we're going to watch them with the thermal imager. And then I've also got the wires pierced here and here going back to the, oh, we're going off the screen. Let's go this way. So this is going to the scope and the multimeter, okay? So we're going to measure the voltage drop across our wiring right there, okay? That way we're able to see what's happening across here. Are we dropping voltage? Are we high resistance across here under load? Because again, resistance tests are not a good way to check wire, right? It only takes one strand to pass a resistance test. But if we put them under load with a 6 amp load here, we're going to be able to see if we're dropping voltage across a bad connection. Okay? So we got the scope and the multimeter hooked up. I got piercing probes in here on both of the wires. And I also have an amp clamp on it. So let's get right into it. Move this guy back out of the way. And snip off these zip ties. All right. So now what, each of these wires, oh, there's a lot of dirt in there. Each of these wires is sealed up. Let's bring up here. Each of these wires is sealed up on the end with liquid electrical tape. So I'm going to just take the wire stripper, strip off each end, and put a bullet connector on each end. But if we look, here's our connections. So we have a control wire here that's got nothing done to it. We got a, an open butt connector. We got an open solder connector. We got a heat shrink solder here. We got a heat shrink connector. So a lot of different connections here. Let's start in on the first one. We'll go with the twisted and taped pair of wires first. That's soldered. This is twisted and taped. Ooh. These are the wires are kind of black and corroded here. They're not nice and shiny copper at all when I strip the ends off. So I'm using the same size bullet connectors for everything, just so we have consistency through this. Everything's going to be crimped down the same way. Okay. So nice and secure. And let's just flip on our power supply. And right now, if we look at the scope, we're reading open circuit voltage on the scope right now, right? So channel A is reading 13 volts because we're open circuited right now. We're measuring the voltage drop, and because we're open circuit, one side is power, the other is ground. Right? If we're open circuit on our, if this is open, we're going to measure power on this side. The ground is going to go through the filament of the bulb, and we're going to hit ground. So we're reading open circuit voltage right now. As soon as I hook this guy up, our light turns on, and our voltage drops down because we're not dropping any voltage across this connection, right? Voltage drop 101. If I start to manipulate this connection, I can maybe get a, I'm not going to be able to get anything consistent, but I could maybe get a high resistance across there, but we'll show that with the connection. So we'll get the thermal imager on here, get this guy turned on. All right, so you guys should be able to see my hand right now. Oh, let's get that up on the screen. We'll go full screen on the laptop right now. There we go. So obviously the thermal imager is currently live, and I have it recording hot spots. So we'll hook this in like so. Feed power into one side. Oh, let's turn our amp clamp on so we can read. Actually, let's turn our amp clamp on so it stays on all the time. All right, so now our amperage for this bulb is, what are we reading? 5.3. Okay, so just under 6 amps, 5.3 amps for this bulb. Now let's run it through our twisted pair of wires and see what happens. Okay, I'm still hooked up. We have no current flow. We have connection on either side. Well, that's uneventful. I think the twisted pair of wires has completely failed. Oh, I just moved it a little bit. There we go. We're getting something to happen. So still pulling 5 amps. We're dropping about 250 millivolts across there. Let's turn the meter on. We can watch that too. 435 according to the meter. So 435 milliamp drop across there, millivolt drop across there. Our connection's getting warm. But now if I start tapping at this, will it go open again? Well, it's actually holding up better than I thought it would. So over time, I bet this thing's going to keep getting hotter and hotter. Let's pull this, maybe I can get this tape off. See what that looks like. Maybe the tape's holding the wires together right now. Yeah, they're kind of corroded. Let's get a close-up shot of that. So they're pretty corroded. They just broke apart. So they're actually in a lot better shape than I thought they would be. But they definitely just did break apart. They're really stiff. All right. So not a good connection. They're actually getting very, very warm. Coming up on 100 degrees here. So let's jump to the next one. And next up is our old wire nut. Here's what it looks like. Pretty nasty looking. Again, the ends are really black on here as well. Actually, these look worse than the one that was taped. Alrighty. Alright, so the bulb lights. Dropping 85 millivolts across there. The wire's heating up, but it looks to be holding up pretty well. Kind of surprised that that's not way worse. Maybe we need a bigger load on there. Maybe something more than 5 amps would cause this thing to act up a little bit more. So, actually, it's not horrible. I mean, it's not protected by any means. The wire inside here is all corroded. But it's handling the 5 amps pretty well. Not overheating. Well, here I thought that 5 amps was going to be enough load to make these things do something a little bit fun. Let's see if this nut comes off. See what these look like underneath. Ooh. It's not coming back off. It's all like fused together in there. It's not coming back off. All right. As much as I want to say don't use wire nuts because they're not protected, this one is working pretty good. But again, guys, none of this has been fed through electrolysis. There's been no current flowing through these, so there's been no electrolysis on these wires for the last 2 years. But if those two are still lighting up the bulb, I think we're going to be pretty good with the rest of these, unfortunately. Let's go to this is just a standard butt connector, no protection on here at all, no tape and no heat shrink. It's not a heat shrinkable butt connector. Let's see what this one looks like. I should get a larger load. A 20 amp load would probably be ideal. Okay, we're lighting up just fine. 90 millivolts a drop. Pretty consistent with the current. Do I have anything around here that's a bigger load? That's too bad. I may have to do a follow-up with a larger load, because all of this stuff is handling it pretty well. But again, this unprotected connection, it's nasty inside of there. You can see corrosion starting, and it's only going to be worse if this wire's been under current for the last multiple years. Let's take a look at, here's a solder connection that was taped. Let's take a look at a soldered connection. This is a soldered connection that was heat shrunk. So this should be our Cadillac of connections. Let's take a look at what those wires look like underneath. Yeah, still black. Kind of surprised. So they're not clean copper underneath there. They're still black. Which leads me to believe that moisture still got in here somehow. Now I would assume this one will flow current through here just fine, but let's take a look. Wire nuts can handle 8 to 10 amps. Okay. But they're not able to handle the vibration, they're not able to handle the pull test, and they don't seal up unless they're like a marine grade one, like somebody else was mentioning. It might work, but I mean, how many times have you been under the dash looking at a homemade, home installed remote start and seen just standard old orange wiring nuts sitting under there? Oh, aluminum wiring, yep, you gotta be careful with that. So, actually, I'm kind of surprised here. Look at our meter. This is our highest voltage drop yet across the solder. So it could be that I have a bad connection in one of these bullet connectors, but I'm a little bit shocked by that. So Paul, your theory is that moisture came through the liquid tape, and that's definitely possible. It's very possible that it wicked its way through the liquid tape. Let's take a look at one that this connection here was soldered and then taped. Let's see what that looks like. Well, unfortunately, this is way less eventful than I was hoping it would be. Here I had the fire extinguisher out. I was hoping wires would start smoking and stuff. Actually, that end is still nice and shiny copper. So the liquid tape must have sealed up pretty good on that end. So I think most OEMs now recommend that you're using a heat shrinkable butt connector style. It's just sad that a lot of remote start kits and stuff are coming with, or aftermarket accessory kits are coming with Scotch locks and stuff. Again, that's an unprotected wiring, and actually a Scotch lock can actually dig into the wires, so just do anything besides that. I mean, they're just a very poor connection. But really our goal here is to not have to take the entire harness apart, because it's incredibly expensive. To restring an entire wire. We want to be able to do an adequate wiring repair that's going to last the life of the vehicle. And apparently, every connection so far has been adequate. I mean, we're really doing, unfortunately, we're really passing every test right now. My favorite car, I don't want to start any don't want to start any drama out on YouTube, so I'm not going to answer that question. Everybody's got their opinion, right? All right, let's just take our control wire real quick, see what that comes in at. Scotch locks should never be used. Bob, I couldn't agree more. If you get Scotch locks with your kit of whatever accessory you're using, get rid of them. Here's the control wire. So again, no connection in here whatsoever. The ends are still shiny, so that's good to see. Obviously, it'll be just fine. Let's just throw some on here quick. Just 2362. How would you know that? How would you know that I'm a Mustang guy? Where do you come up with this information? I figured somebody would say it. I have owned Mustangs in the past. All right, there's our control wire, 81 millivolt drop. Works pretty good. I'm sorry, guys. I thought this was going to be something that was going to be really exciting. I was really looking forward to this experiment and seeing what these would look like after 2 years on my vehicle, and it's been sadly uneventful. Sadly uneventful, but just looking at this wire nut, looking at the way this wire looks under that twisted pair, anything that's exposed and flowing current is going to corrode, okay? It's not going to last the life of the vehicle. You need a covered, weather-sealed connection that's going to last. The only downside to any connection in the wire, anytime you take and you put anything in the wire, whether it's a crimpless connection like this, whether it's a soldered connection like this, you now have a stiff spot in the wire, right? Let's go zoomed in here. You can see I can't bend where the solder is, right? That's right where my solder sits. It's a stiff spot. Can't really bend this. This one's a little bit more flexible, but you don't want to be putting this kind of stuff, any wiring repair, like somewhere that's going to move, like a door jamb. If you're doing door jamb wiring, right, driver's door jamb, the wiring fails pretty commonly. You have to do wiring repairs there. Don't put a connection back in the door jamb. Every time that door opens and closes, it's bending where that solder ends or where the crimp connection ends or whatever you do. Your best bet is to cut the wire inside the door, cut the wire under the dash, run a new piece of wire in there, maybe a foot long, something like that, and then connect on either end. So that way there's a fresh piece of very flexible wire within the door jamb, okay? That's going to keep it from being a comeback repair a year later when that spot could be moving like this all the time. This will break eventually, right where the solder ends. I can already feel it getting weak just from the few times that I've done it here. There you go, okay? So be careful with stuff like that. You don't want to put it in a spot that's going to be moving a lot. If it's a spot that moves a lot or there's a lot of vibration, you're going to want to somehow isolate that or wire it on either side like in the door jamb. Let's see here. I should get a larger load. I'll look into getting maybe a 20 amp load. I think I'll try to find something. We have some stuff here that engineers use to load test some stuff. So I'll find a larger load. Maybe I'll just do a 5-minute follow-up video with some of this stuff under a 20 amp load. We'll do some film magic and speed things up so you guys can see how hot they get. Because when I did a video probably about 2 years ago, we did this same thing and we put these in a salt bath, and I was able to get a reaction out of them with a larger load. I was running this light plus some smaller ones in series, and that was in parallel, and that was pulling a larger load on there. So unfortunately it was less than exciting, but what does the soldered and heat shrunk look like under the heat shrink? So you want me to open up this heat shrink right here? I can maybe give that a shot. Let me grab a knife real quick. I don't know if I'm going to get this heat shrink back off of here, though. It's sealed up pretty nice. This is probably the point where I cut my finger live on camera. Let's see. No? Look at that. It's actually pretty good looking. A little bit of corrosion in there. Right? A little bit of flaky dust in there. But I think this is some cheaper heat shrink because it wasn't really bonded to the wire at all. So I don't think there's glue in this stuff. Buy the heat shrink with glue in it. It seals up a lot better than this stuff does. But yeah, the connection looks great. And we saw that, right? I mean, under 5 amps, it wasn't having any issues at all. You guys are in class right now? You guys are in class watching a class? What does Saturday heat shrink look like? All right. Anything else that you guys want to see? I'm going to look for a larger load to run these through and see what happens. That way we can hopefully see something exciting from these connections. I'm going to pull this tape off this one here and see what this looks like underneath. See if it's better or worse than the heat shrink. Because I know this is good tape. And tape's the same way. Same thing with heat shrink, with connections. You know, it's one of those get what you pay for type of things. You don't want to get the cheapest stuff you can find. Actually, look at this, guys. All right, so this is a heat shrink, which was a discount heat shrink that I found compared to some high quality electrical tape. Look at the difference. The one that had the electrical tape on is still shiny. There was no dust. So high quality electrical tape in this case is better than low grade heat shrink. Okay? There's a lesson. I knew I could find it somewhere. All right. And liquid electrical tape seems to work pretty well, though I'm a little bit surprised at the amount of how much the copper has oxidized. So maybe it's not sealing up as strong as we thought it would. All I did was dip each end of the wire in the liquid electrical tape, take it out, and let it dry. All right. Just grab another load right now. It's not that easy, unfortunately. All right, did I miss anything? Anybody want to see anything else before we close this out? Oh. But wait, we got a t-shirt question, right? At least now we know that bullet connectors suck. Yeah, they do. They do suck, but I wanted a consistent connection here across all of them, and they're cheap to use. So obviously we're never going to use bullet connections like this on a vehicle, but I wanted something that was quick and easy to do for you guys to be able to see. How about one of those sweet teas? All right, let's take a look at the question. So I'm going to actually draw it out here. All right, so we have battery voltage coming in, feeding power down to, call this bulb 1, okay? Bulb 1, small little bulb like this, okay? The resistance spec on this bulb is 2.5 ohms, okay? This bulb then runs down to bulb 2. This is bulb 2. The ohm spec on this bulb is 0.5 ohms, and then we run to ground. Okay? This is what our question is based off of. Bulb 1, bulb 2. Okay? Makes sense? 0.5 ohms for bulb 2, 2.5 ohms for bulb 1. The question is, what is going to happen? When we hook power up, we feed power. Oh, Did I just kill the laptop? Hello? Uh-oh. Uh-oh. Uh-oh, come on. All right, we're good. Let's try that. Okay, there we go. When we hook up power and ground to this circuit right here, Technician A says only the small bulb, bulb 1 will light. Technician B says both of the bulbs will light. Technician C says only the large bulb will light. And Technician D says that neither bulb will light. Who is correct? Do you want to pull that one down so they can see my email address? There you go. So there's my email address. The giveaway is only valid for today, okay? April 4th, 2019. The first 5 people to send me out an email with the correct answer and why that answer is correct will win one of these sweet tees, all right? One of our new NGK Tech shirts. All right, the first 5 people. If you won last month, I'll bump you down the list. You're on the list, but you're towards the end. We're going to try to get everybody into one of these before people get seconds, okay? All right, bulb 1, bulb 2, which one lights, okay? That is the question. Send me out an email. All right, anything else? You guys send me out an email. It's not going to work in the chat section here. Send me out an email to the email address that was on the screen. Let's put that back on the screen so they have it. Thank you. Right here. Send that out to my email address right here with your answer, and I will respond. And if you were the first 5 to get it, you will win a shirt. All right. All right, so again, 4 wire connections that I would consider to be acceptable, 2 different splices, a heat shrink butt connector, and the crimpless style connection. But I have a feeling if I pull hard enough, I might be able to separate this one, and actually I can't. So our crimpless style by hand here, pulling apart, will not come apart. So it does hold a pretty good amount, or I'm just really not very strong. But in the machine, when we put it in there, it was reading a lot lower than a crimp or solder style connection. But in the grand scheme of things on a car, there's very, very few times when we should be having to have any wire harness under any of that stress. Vibration and corrosion are our 2 biggest factors that we have to battle against, okay? All right. Yes, I will put the question back up on the screen. Can we make that full screen again? There we go. Again, Technician A says that only bulb 1 will light up. Technician B says that both will light. Technician C, only the large. Technician D, neither of the bulbs. Who is correct? Okay, there's our bulbs. Alrighty. I did not eat my Wheaties this morning, you're right. All right. Did spend the last weekend in New York at the TST training event. Another fantastic event, fantastic training from awesome trainers in the industry, along with even better networking with other people from YouTube, other technicians, people from really all over the world. There were people there from Australia, Brazil, the UK, Canada, people from all over. So if you aren't getting to these events, definitely try to make it next year. They're very, very much worth, it's incredible. Just, you got to get there. You got to go. Vision in Kansas City in March, TST at the end of March, beginning of April. They were just fantastic events. Try to get there next year. Really hope to see you there. I think that's going to be about it for today. Hopefully, hopefully you guys have sent out your answers. Kevin wanted me to sing a birthday song for him. Well, happy birthday, Kevin. I'm not gonna sing. My voice is pretty raspy from my cold anyway, so definitely would not be a American Idol winning performance, unfortunately. I guess in the gist of it, the long story short here, just make sure your wiring connections are protected and they're a solid connection. I'm going to find a larger load, do a follow-up video on here, and hopefully we see something fun. Oh yeah, Super Saturday in October out in Pennsylvania. So make sure to sign up for that one. Unfortunately, I will not be attending that one, but you know, if you're available in October, sign up for Super Saturday. Alrighty, I think that's going to be it. Again, t-shirts there, so hopefully we can get 5 of those sent out yet today. Thank you everyone very, very much for watching. I wish this would have been a little bit more exciting. I kind of was looking forward to using the fire extinguisher if I needed to, but we'll see what the follow-up has. And all right, well, until the follow-up video, thanks again for watching. If you like this, please give us a thumbs up, subscribe, hit the little bell so you get notifications. Excuse me. And again, thank you for watching, and we'll see you in the next one. Happy wrenching, everyone. Thank you.